Student, today we will learn the chapter Application of Derivatives. As in the previous video, I have already explained rate of change. In this part of this, I will going to be explaining you approximation. So using the differential, we are going to be find the approximations. Okay, now first I will tell you what is the meaning of approximations. And you know that under root 25 is 5, and so we can see under root 26 is slightly greater than 5. Since 25 is greater than 26, so we can say 5 here. So 26 square root of 26 slightly greater than 5. Okay, so you have to what the slightly greater than, that you can take approximate. Okay, so what the approximate we have to find by using the derivatives. It will be helpful to find the approximate value in easy way. And you want to be find the value of x to the power 17 by f1. So you can say easy way that it is 17. But if you want to find it by 1.1, so calculation of 1.1 directly to putting here, it is very difficult. But for approximate value, if you want to find it using this derivative, so what is the approximation method? We can find the very easy way, lump sum value, approximate value. Okay, using the derivative. Okay, student. So I am going to tell you in detail of this formula. Now you can see if let y equal to fx, if slightly change in x, let that is delta x. So here is also slightly change, that is delta y. Let it is equation 1, equation 2. Now 2 minus 1, what we got? Delta y equal to fx plus delta x minus fx, it is original value. And we can say if we divide it by delta y by delta x, and delta x tends towards 0, is a very small change in delta x, then what we know that this is known as first principle, and now this is known as dy by dx. So derivative of y with respect to dx. Okay, so now delta y by delta x tends towards 0 is known as derivative of y with respect to dx. And now you can see in this curve, that at this point here is a tangent. Let at this point we take these two type of the point. One point is Q on curve and P on tangent. And you know this angle is theta, then tan theta is dy by dx, slope of tangent. Okay, so here we can say it is dy, it is dx. So it is tan theta is perpendicular this one, and this one is dx. Now in this triangle we can see it is delta y and it is delta x. So we can say here delta y is not equal to dy, but delta x is equal to dx. Okay, so we can say here is a very important point. If we can say delta x tends towards 0, very small value, then we will take then we will take delta y. This change is here equal to dy. Okay, so here what we have learned, this important point, we can write an important note that we may note that the differential of the dependent variable dependent means y variable is not equal to the increment of the variables. Means we can say dy equal not delta y, where as the differential of independent variable means x is equal to the increment of the variable, means dy is equal to dx is equal to delta y. But here we will take for small value, but here we will take for approximation delta y equal to dy. Okay, so now we can say fx plus dy by dx, if we write here dy equal to dy by dx into delta x, since this is equal, so we can write here. Okay, so now fx plus delta x equal to fx plus delta y, and what is the change in y? That is dy by dx into delta x. Here is the change in variable. Okay, so now do the questions. Use differential to approximate of under root 36.6. Okay, so here we can say this function is just like as under root x, and we can say x equal to 36 and change in 36, that is delta x is 0.6. Okay, student, we always take the x this way, that if there is a root, so we can take the square root easily. Okay, if we, according to this, we have to divide it into two parts, x and delta x. Okay, student, so we can say delta y equal to under root x plus delta x minus delta x. So under root x plus delta x equal to under root x. So we can say it is delta under root x plus delta y. Okay, so we can see under root 36.6 is equal to under root 36 plus dy by dx into delta x. So change in y equal to differential of fx equal to root x, so f dash x equal to 1 by 2 root x. So f dash at 36 equal to 1 by 2 root 36 1 upon 2 into 6. This can be right here 1 upon 2 into 6 into delta x is 0.6. So we can solve this in a very easy way, that we get the value of 6 plus after cancel out this we can say that is equal to 0.05. So your answer, required answer is 6.05. Okay, now this way if we want to find another question, find the approximate value of f3.02 where fx equal to 3x square plus 5x plus 3. Now you can see it is not given in the question by differentiate, but you have to use the differentiate. Okay, now you can see if you put directly 3 here, then it will be easier, but if you put directly 3.02, the calculation is not easy. So we can say f3.02 is equal to fx plus delta x, and okay, so fx plus delta x equal to fx plus dy by dx into delta x. Here we can say here fx equal to 3x square plus 5x plus 3. So f dash x means dy by dx equal to 6x plus 5 into 1 plus 0. So f dash is 3 is equal to 6 into 3 plus 5 equal to 18 plus 5 23, and here we can say delta x is equal to 3.02, so that is 0.02. Now fx equal to f3 equal to 6 into 3 square plus 5 into 3 plus 3. Solving of this we can get the value of that is equal to it is 3x square plus 5x plus 3 square 9 into 2 27 plus 15 plus 3, that is equal to 45. Now we can find the value of this one. Hence f3.02 equal to f3 plus dy by dx into delta x equal to 45 plus dy by dx we got 23 and delta x is we got 0.02, and solving of this we can get 45.46. So this is the required solutions. Okay student, so if we have to find the change only, then you can find this answer only. One more questions I want to describe you, that find the approximate change in volume V of a cube of side x let the side in meters caused by increasing the side of by 2%. So we know that volume of cube is V equal to x cube, and we have to find the change in volume delta V, that is dV is equal to dV by dx into delta x. Okay, so now here we can say dV by dx equal to 3x square, and delta x is equal to 2% of side, so means 2% of side is equal to 0.02x. So we can put here value 3x square into 0.02x. So we get here 0.06 x cube. Okay, since it change in volume meter cube, so we can say approximate change is your answer. Okay student, this way you can find the approximate value, right? If you want to be change only, so you have to find only this change. Okay student, so in the next part I will tell you the more applications of derivatives. Thank you for watching.